this example, we have a limit and a function. So what we're going to do is we're going to try to use direct substitution in order to solve this limit. So by using direct substitution, we just go ahead and plug in 0, and we get the square root of 1 plus 0 minus 1 minus 0 divided by 2, all divided by 0 squared. So this becomes the square root of 1 minus 1 over 0, which is going to give me 0 over 0. Well, this does not tell me anything because 0 over 0 is in indeterminate form. So what we need to do now is apply L'Hopital's rule on this problem. So by using L'Hopital's rule, we get that this is the limit as x approaches 0. The derivative of the square root of 1 plus x is 1 over 2 square root of 1 plus x. The derivative of negative 1 is 0, and the derivative of x over 2 is 1/2, all divided by the derivative of the denominator, which is 2x. So now we're going to go ahead and try a direct substitution and see if it works. So we can write this as 1 over 2 square root of 1 plus 0 minus 1/2 divided by 2 times 0. So I get 1/2 minus 1/2 over 0, which gives me 0 over 0 again. So yet again, we got indeterminate form, and which means we can use L'Hopital's rule yet again. So we're going to use L'Hopital's rule again. And in order to do this, I'm going to actually rewrite this a little easier before I apply L'Hopital's rule. So this becomes the limit as x approaches 0 of 1/2 1 plus x to the negative 1/2 minus 1/2 divided by 2x. And the only reason I did that was to make the derivative a little easier. So now we're going to apply L'Hopital's rule. And by applying that, we get this negative 1/2 is going to come down to the front. So we get this is the limit as x approaches 0 of negative 1/4 1 plus x to the negative 3/2. The derivative of 1/2 is 0, so it's going to go away, all divided by 2. And so at this point, we can go ahead and plug in our limit, and we get that this is negative 1/4 1 plus 0 to the negative 3/2 divided by 2, which is going to become negative 1/4 1 to the negative 3/2 divided by 2. So this is negative 1/4 divided by 2, which becomes negative 1/4 times 1/2, which is negative 1/8. So the limit of our crazy function in the beginning is actually negative 1/8. And we get that by using L'Hopital's rule. Not only once, but we use it twice. So on your own right now, I want you to try to determine the limit as x approaches 0 of 1 minus cosine x divided by x squared. Alright, let's see what we get. So first things first, we're going to try a direct substitution. So we're going to get 1 minus cosine of 0 divided by 0 squared. So this is 1 minus cosine of 0 is 1 over 0, which is going to be 0 over 0. Because of this, we know to go ahead and use L'Hopital's rule, because we have a 0 over 0. So the first thing I'm going to do is rewrite my function as the limit as x approaches 0 of 1 minus cosine of x over x squared. And then by using L'Hopital's rule, we get that this is going to be the derivative of cosine is negative sine. And so this is going to become positive. So we get sine of x, the limit as x approaches 0 of sine of x divided by 2x. And so from here, we're going to try a direct substitution. And we get sine of 0 over 2 times 0, which still becomes 0 over 0. This means that we have to use L'Hopital's rule again. And we get the limit as x approaches 0. The derivative of sine is cosine. And the derivative of 2x is 2. And now we're going to try our direct substitution again. And we get cosine of 0 over 2, which is 1/2.